let's understand how we find the area between the two curves. Okay. Now here, let's say, okay, let's take the x-axis and y-axis. All right. Say you have x and y-axis. Now say there are two graphs or two curves, you can say. Hmm? So let's say one curve is something like this. This is a one curve. Say we have one more curve. Say something like this. Say this is another curve. Now, between these two curves, there is one region where you have to find the area of that. Okay, let's say I'll ask you find the area of this particular region. See here, this region. This region. Now, to find the area of this region, see what do we have? We have two curves, right? See, this is f of x, and we have one more. See, this is g of x. So we have two curves. Look, for this particular region, we are trying to calculate, the first thing what we need to do is find the points where they intersect. In the sense, we are looking at this point and we are looking at this point, these 2 points. Because these 2 points, they cover this area, isn't it? That means here we are looking at, so first let's take this one, let's take this one. So these 2 points. Now here, say this point is A, say this point is B. Okay, so 2 points A and B. That means the point of intersection, we can say this is x1 comma y1 and say this is x2 comma y2. Okay, x1 y1 x2 y2. Now to find the area between them, so what we can do is integration from A to B, that is starting is A, ending is B. A to B, which is the top curve, which is the above curve. Above curve is nothing but f of x. So we have f of x minus the below curve g of x. Okay, f of x minus g of x. Why we take f of x minus g of x? That means, see, if you take f of x, see what you have a curve something like this, correct? Now, when you take this, you're finding this entire region. But do you need entire region? No, right? You need only one part of it. But to find that, what you do, you take the whole area. Then, in this one, see, g of x is like this. You subtract this g of x area. What remains? That is what is required. That is f of x minus g of x, right? That is why what we do is that area A is equal to integral from A to B f of x minus g of x dx. So this gives us the area, the shaded area, okay, or the required area. Now let's do an example. With an example it's always easier. Okay, now let's start with an example. See, for an example, see what you can do. We can take two parabolas. Okay, intersection of two parabolas we can take. Now let's start with very simple ones. What we already know. All right. Let's say you have the x-axis and y-axis. All right. So this is the origin. Now let's start with the first equation. Say y square is equal to x. A very simple equation. And since it's y square is equal to x, it's a right opening curve, correct? So the first curve is going to be somewhere something like this. See, this is y square is equal to x. Now let's say we have another parabola. Okay, let's say we have y square is equal to. Now again we'll do y square, but we'll do the other way around. That is it. Let's make it as a left opening parabola. Huh? So we can take y square is equal to minus. Instead of taking minus x, we can take minus of x minus 3 whole square. Sorry, minus of x minus 3. That's all. Okay, so in this case, 1, it's a left opening curve. Second, it has been shifted towards the right side by 3 units. That means we are looking at a point here, and the graph is going to go something like this. See here? This is the curve. This is the second curve. Now, what we are looking at is this one. See, this is the point, or this is the region where both of them are going to intersect. Now, to solve, how to find the area of this, it's very simple. First, what we do? First, we are going to find the points of intersection, this one and this one, and we can find the area within. Again, it depends on problem to problem as to how do we split the area, because not every question or not every combination of curves can be solved in the same way. So it's all of them are different anyway. That means in this case, since we have those 2 points, we divide them, and we divide accordingly and then find the area. Now this is how we are going to do it. Fair enough. This is the way how we are going to plot the graph. Then once you have the graph, find the 2 points and then find the area between the two curves. Clear? This is what we were discussing in the in the previous part. That is, what you do is you do f of x minus g of x. You subtract, then integral from a to b dx. This gives us the area, isn't it? So this is what we are going to do. Fair enough? Now, from the next video onwards, we'll start with the problems. And as we are doing the problems, you guys will understand how to find the area, how do we find the points, and how we use the points. Fair enough? So, from the next video onwards, we'll start with problems related to finding the area between the two curves.